You know that feeling, right? You're trying to learn something new, and it feels like you've just slammed into a brick wall. There's this one concept that, no matter how many times you go over it, it just won't stick. Meanwhile, other ideas just kind of click into place effortlessly. Well, today, we're going to unpack the science behind that exact feeling.
And let's start with a classic, one that trips up so many of us: high school physics. For a lot of people, it's just this minefield of concepts that seem to go against everything we experience in our daily lives. So why is it so tough? The answer, it turns out, is way more fascinating than you might think.
To really get to the bottom of this, we first need to look at the very specific ways we get physics wrong. See, it's not just random. The research shows that students often have these incredibly specific and really stubborn wrong ideas. Just take a look at these common beliefs about things like momentum and impulse. A surprising number of students are absolutely convinced that a ball will bounce higher than where it started, or that a longer impact automatically means a bigger impulse. These aren't just wild guesses. They're consistent, fully formed, and totally incorrect theories about how the world works. And this right here, this gets to the absolute heart of the problem. The issue isn't just a simple lack of knowledge. It's something much deeper. It's the presence of a deep-seated, confident misunderstanding. Students aren't saying, "I don't know." They think they know, and they're sure they're right. So you can imagine, this creates a huge challenge for teachers. How in the world do you tell the difference between a student who's just taking a wild guess and one who's holding on to a really fundamental misconception? Well, for that, you need a much smarter tool. And researchers have developed something that's, well, it's kind of like a CSI for wrong answers. It's a way to do a forensic analysis of a student's thinking to find out what's really going on inside their head. Okay, so how does this whole CSI thing work? It's called the 4-tier diagnostic test, and it's actually pretty brilliant. It's a 4-step process. First, a student picks their answer. Simple enough. Second, they rate how confident they are in that answer. Third, they pick the reason for their answer. And finally, they rate their confidence in that reason. It's these layers, especially the confidence ratings, that reveal everything. And this is where it all comes together. The test lets us see a crystal clear pattern. A student who just doesn't know the material will get the answer wrong and pick the wrong reason, sure, but they'll have low confidence. They're guessing. But the student with the misconception, they get the answer and the reason wrong, but with high confidence. They're absolutely certain about their broken model of the world. All right, so now that we have a tool to actually identify these confident wrong ideas, we can finally tackle the big question. Where do these things even come from in the first place? The data from a study in one high school physics class is really telling. Just look at this chart. These misconceptions are everywhere. Almost no one is in the low category. The vast majority of students are wrestling with a medium or high number of them. This shows us that these ideas aren't a rare bug in the system, they're a normal part of learning.
But what's really interesting is when researchers looked at the causes of these misconceptions, one reason just jumped out from all the others. It's called humanistic thinking, and it's responsible for almost 30% of the mistakes. So, what on earth is that?
Well, humanistic thinking is basically our tendency to give human-like intentions to inanimate objects. For example, a student might think that a longer impact time wants to create a bigger impulse, as if the object has a goal or desire. It's a very natural way for our brains to make sense of the world, but in the world of physics, it leads you way off track.
The next biggest cause is what we call preconceptions. These are just the ideas we build from our everyday lives before we ever set foot in a classroom. You know, we see heavy things moving fast, so we develop a gut feeling for momentum that's all about mass and speed. But physics tells us direction is just as important. A little detail our everyday intuition tends to ignore. So now that we kind of get the problem with these sticky misconceptions, let's zoom out. Because it turns out this isn't just a physics problem. Not at all. It's all explained by this really powerful universal theory in education about how we truly learn the hard stuff.
And this big idea has a name. It's called a threshold concept. The researchers who came up with it used this powerful line to describe it, and you've got to hear this. A threshold concept represents a transformed way of understanding without which the learner cannot progress. Just think about that for a second. An idea is so important that you literally cannot move forward without it.
The best way to think of it is as a conceptual gateway. Before you walk through it, a subject can seem like a confusing, jumbled mess. Getting through that gateway is often really hard and frustrating. But once you do, your entire understanding is transformed. And here's the kicker. You can't go back. You can't unsee it. And this is the part that is so cool. It's not just physics. Every single field has these gateways. In literature, it might be truly getting the concept of irony. For an accountant, it's depreciation. For a geologist, it's wrapping your head around deep time. In every case, once you get it, the entire subject just snaps into focus in a new way.
So once you realize these thresholds exist, it completely changes how you should think about both teaching and learning. It's a total game changer.
It suggests that a teacher's real job isn't to just stand up there and deliver a curriculum, to just pour facts into your brain. No, their core job is to get students to actively wrestle with these troublesome ideas and to be a guide to help them through the confusion and across that threshold.
And for curriculum design, it really points to a less is more approach. Instead of trying to cram a course with tons and tons of information, the focus should be on figuring out the few key threshold concepts and then spending the time to really help students master them, because without those, none of the other facts are going to make much sense anyway.
So, that brings us right back to you. I want you to think about your own journey, in school or just in life. What was that one idea you really struggled with, but once it finally clicked, it just fundamentally changed the way you see everything? That was you, crossing a threshold.